Welcome to Sundar's lecture. In this lecture, we are going to see what is real power and reactive power, basics of real and reactive power. So I will write here in this lecture. We are going to see basics of basics of real and reactive power. Basics of real and reactive power. So before entering into the real and reactive power, I wish to give you two basics examples first of all, so that you can easily understand what is real power and reactive power. So I will give you two examples. Two examples. One first example, that is purely technical example. Technical example. Technical example. Okay, fine. Now, in this technical example, I am going to take an electric circuit with a source, and this source is connected to a load. So, like this, it is connected. So, I will mark this. So, this is my plus, minus, this is my V, and this is my load, which is I have denoted it as EZ. So, this is my load. Now, in this load, in this circuit, how my current will flow? So that is my primary question. So I am assuming that if my current is flowing like this, that means my current is flowing, which you can easily understand that wherever you see a source, in a source, for sure your current will flow from minus to plus. If the current is flowing from minus to plus in source, then it is delivering power to the circuit, delivering current to the circuit anyway. Now you see here my current is flowing from minus to plus in source, so that the source is generating power to the load now. So if current is flowing from minus to plus in the source, then obviously your load will get plus, this is my plus, this is my minus, which means I am marking this polarity based on the voltage polarities. Now you see my current is flowing from plus to minus in the load. So I can consolidate and I will write here that in this condition, maybe I will take it as case 1. In this case 1, you see current, that means flows, I flows from source to load. Current is flowing from source to load. You see it is flowing from source to the load. Then you can obviously see that my power. So under this condition, under this scenario, what happens to the power? Power will be positive. Power will be positive, which means my source is delivering power to the load. That is the thing you have to understand here. So now I am going to the case 2. Here I will take the same circuit. This is the voltage source and this is my load, and I am connecting these two in the series, and we know that this is my plus minus V, and this is my plus minus, this is my Z. Now what happens here, you see, if my current is flowing like this, which means you see here my load is pumping back the power to the source, which means in load my current is flowing from minus to plus, in source my current is flowing from plus to minus. So that what happens here, load is pumping back power to the source. If you may know the example of these kind of loads, that means inductors and capacitors are all the loads which will pump back the power to the source, right? So I will write here in the case 2, what happens in the case 2. So here I will write current I flows from load to source. So you can easily see that power in this scenario, in the case 2, will be negative. Will be negative. Current in power in the second thing will be negative. Negative. So I will now, okay, at last, what we have to understand here, you see, if my current is flowing from source to load, if my current is flowing from source to load, then obviously I can see my power will be positive in the circuit. Likewise, if the current is flowing from load to source, if my current is flowing from load to source, then obviously I can see that my power will be in negative, right? This is my technical example. Next, second thing, second, non-technical example, non-technical, non-technical example. So in non-technical example, you try to understand what I'm going to tell you now. So I have a seller. I have a seller here. So I will write here. I have a seller. I have a seller and I have a customer. I have a customer here. This seller is now having 100 bags. This seller is having 100 bags of rice. 100 bags of rice. Now what this seller is doing now is sending this 100 bags of rice to the customer. This seller is sending the 100 bags of rice to the customer, right? Now what this customer is doing now, he is getting or he is utilizing 80 bags of rice. 80 bags of rice. And what he is doing, he is now returning back that 20 bags of rice again to the seller. You assume that this is the scenario, and you see that you can easily relate these all things to the power in an electrical network. How this can be related? You see, I'm going to relate this 100 bags of rices. This 100 bags of rices, I can call it as this 100 bags of rices, I can call it as apparent power. Apparent power. And this 80 bags of rices, I can call it as real power. Real power. And this 20 bags of rices, I can relate it to reactive power. And you see now, you can easily say that now you can relate now. So if this seller is giving 100 bags of rice to the customer, but what this customer is doing here, this customer is only utilizing the 80 bags of rice and he is actually returning back 20 bags again to the seller. And what happens to this 20 bags of rices? This is actually a loss to the seller, because all the transportation costs were taken care by the seller. This customer is only receiving. Anyway, my students will ask me one question. Everywhere if I am giving this particular example, they will ask me that, okay sir, no problem, 20 bags of rices has been returned to the seller again. Can the seller again he can sell this 20 bags of rices to some other customer? But you see, it is not possible in the AC circuit, because I am relating this particular example to the AC circuits. This is actually AC power. Apparent AC power has been sent to the customer. This is my customer, and he is utilizing the 80 watts. Maybe you take it as 80 watts of real power, and he is returning back the 20 watts of reactive power to the seller. This, you know that AC powers cannot be stored once it has been generated, you have to use the AC power. There is no storage for AC power. So this example you cannot exactly relate it to the real and reactive power. Anyway, to understand the things, I have given this example to you, right? So with these two examples, we can easily understand what is real power and what is the reactive power in the next lecture. In the next lecture, what I am going to take, I will take it as a example, as I will write here anyway. I will write here. I am going to take my voltage. Maybe my circuit V is equal to Vm sine omega t. This is my voltage sine omega t. My maximum voltage has been in sine wave, and my current I am taking it as Im sine omega t minus theta. What is this actually? What this means? What this means? Which means I am going for lagging power factor. Lagging power factor load. Lagging power factor load. Right? So how my circuit will looks like now? My circuit will be, this is my source and this is my load. So I'm going to take this circuit in the next class, and I will explain you what is real power and reactive power with the mathematical proofs. That's all. This is my V, this is my R, and this is my L. Right? So what is the current flowing here now? This V, which is nothing but Vm sin omega t, and this is nothing but my I. What is my I? I is equal to Im sine of omega t minus theta. Why minus theta is coming? And this is because of this inductor. We will take this current and voltage equations, and we solve the and we derive the expression for power, and in that power itself, in that power expression itself, we will get the real power and reactive power, not exactly, but by seeing the graph, right? We will see in the next lecture. Thank you.